Okay, this is another example where we're going to find the regression line and then we're going to predict y using x. Okay, so the first thing we want to do, oh, I should say this is number 7, the homework examples, is number 6 in the actual homework. So the first thing I'm going to do is I'm going to go ahead and put the salaries, the television salaries, television stars salaries into list 1 and the viewers into list 2. Okay, I went ahead and did that, but if you need to pause and plug those in, you certainly can, and then come back when you're ready. Okay, so now that I have those in, I'm going to hit second quit, and I'm going to go to Stat, Calc, and I'm going to go under number 8 again. And this is what shows up. So this is my A, this is my y-intercept right there. And then my slope is what's multiplied to x, so this is my slope right there, and we rounded. And then finally we need this value of r, and so it's negative 0.159. So I wrote that down as well. Okay, so that's the first part. Now we're going to talk about the prediction part here. Okay, so to find out if they're correlated, we have to decide, we have to look at the value of r from the sample and compare it with the critical value from the table. Okay, up here it says alpha is 0.05. This time they gave it to us. N is how many pairs? 1, 2, 3, 4, 5, 6, 7, 8 pairs. So just kind of showing the table here. This is on the formula packet, and it's also some of the other homework problems. N is 8, and alpha is 0.05. Let me just zoom in there so you can see it. Here we go. So it's 0.707. And I wrote that right here. Okay, so are they correlated? The way we decide that is we compare the value of r, the absolute value of r, with the critical value. In this case, it's smaller. Let me just show you that. So they're not linearly correlated. Okay, so they're not linearly correlated. I'll just kind of show you that again. So the calculators, the sample value of r is less than critical value, so there is not sufficient evidence to support that there's a linear correlation between the two. Okay. My dog is chewing a bone in the background. I hope you can't hear it, but that's what she's doing, in case you can hear something in the background. Okay. So the next, actually, I'm going to pause this and move her, and I'll start this other part in a minute. Okay, so now for the predicting part, we know that they're not correlated. So it really doesn't make sense to use this regression line because they're not correlated. And I'm going to show you this. Again, I'll put this on Canvas. The top document has to do with the correlation, and this has to do with the prediction. So this is like the second part of the question. And this is also the PowerPoint, but I made it bigger. Okay. So in this case, they're not correlated, so it really doesn't make sense to use a regression line. And in that case, the best predicted value of y is the average of the y's. Okay, so what that means is, it doesn't make sense to use this line. So anytime you're trying to predict y, what you want to do is find the average of these values, the mean of these values. And I'm going to show you how to do that with the calculator. Okay, so if they are correlated, you go ahead and use a line. We did that in the other example. You plug in value of x. If they're not correlated, you just go ahead and find the average of the second variable. Okay. So how do we do that? Okay, I already have these in my calculator, so let me show you a quick way to do that. So I have, if you kind of go back here, I have my x's in list 1. I want my list 2 is right here, and I want to find the average of these. There's a couple different ways to do this. The way that I always show in class, and again, it's kind of up to you, is what you could do is you go to Stat, Calc, and then go under 2 variable stats, and that will give you the sample statistics for the first variable, and that'll be under x, and the second variable, which will be under y. Okay, so this is the average of the first variable, which we don't care about. We care about the average of the second variable right there. So this is the average of the viewers. That's what we care about. So the answer would be that. I'm just going to show you that again. So the answer is right there. That's a y bar. I'm just going to show you again. That's your y bar. So it's 6.11. And then they have you around that there. Okay, and then of course there's one more question. Is this number close to the actual number for 8.2? I would say no, it's not really that close. So I would say no for that one. So that is the last problem from this class. So congratulations, you made it this far. So this should be, towards the end of the section for the last section that we cover.